Hello, friends. My name is Mikhail Abakumov. I'm Reasonable Faith Chapter Director in Ukraine. And today with me, Dr. Andrew Loke, is a brilliant Christian philosopher, author of many academic books about Kalam Cosmological Argument, about Teleological Argument, and so on. And today we are going to discuss his recent debate with Dr. Daniel Linford. And we're going to discuss some key points of this debate. And if you want to watch this debate, you can find link in the description of this video. But I think it was great debate. It was very high level debate, and so not everybody could understand this ideas that you shared with us. So let's try to explain some background of this debate and what is the key idea of this debate.
Thank you, Mikhail. It's very good to speak to you and to discuss this debate together. And I also want to begin by expressing my appreciation to Dr. Daniel Linford and Cameron for this debate. They put in a lot of effort into preparing and organizing this debate. And Daniel and Dr. Linford is one of the leading critics of the Kalam cosmological argument. And so it is very good opportunity to interact with him and to see what are the strongest objections to the Kalam argument right now, and to respond to those objections. Now, during the debate, there was a time control, and so this makes me speak very fast, and I was very short of time, and so I focused only on defending the essential points, the key points of my arguments, which is sufficient for showing that there is a first cause, creator God. But now we can really slow down and explain my thoughts on some points in greater detail. Let me just dive right in to explain about the background of the debate. For the Kalam cosmological arguments, there is a philosophical version and there's also a scientific version. By scientific version, I refer to those that depends on the findings of science. Let's say, for example, those versions that tries to argue that the universe has a beginning by appealing to the Big Bang theory or the BGV theorem or the second law of thermodynamics. Right, so these are scientific theories. Now, whereas the philosophical version doesn't depend on these theories. Now, Linford has objected to both versions, to both the scientific and the philosophical versions. So, for example, he has published in a number of philosophy journals raising philosophical objections to the philosophical version as well. And he has also objected to the scientific version too. Now, for myself, my work focused more on the philosophical version. Why? Because I think the philosophical version is more rigorous. I think that one can offer deductively valid proof with true premises to prove the conclusion, and therefore know that the conclusion must be true. Right? So the philosophical version is more rigorous in that sense. And so I have defended the philosophical versions, make some important contributions to the academic discussion on the philosophical version, and I have also responded to Linford's objections in my publications. Okay, so this debate was initiated by a student at Biola University, Ali Haitov. He has read my publications and saw how I responded to Linford, and he thought that it would be a good idea to get both of us together to talk about the cosmological argument. Now, it's interesting to know that initially Linford declined. He initially didn't want to debate. Why? Because I was telling him that I want to defend the philosophical version. Whereas he mentioned in the email that he is more interested to debate the scientific version. And now I explained to him that I'm not a scientist. I make contribution to the philosophical version, and I personally think that the philosophical version is more rigorous. And I also highlight the point that Linford, has also objected to the philosophical version before, right? So we can talk about that. But he initially declined. He says, if Andrew is not willing to debate the scientific version, and I'm not interested to debate the philosophical version, I don't think there's much for the two of us to discuss. So that's what he said in the email. And so we went on for a few more rounds of emails. I was trying to tell him that, well, you have objected to the philosophical version, and I'm responding to it. And then one day he suddenly replied by suggesting the motion of the debate. In light of contemporary physics, we should not accept the totality of physical reality had a cause or a beginning, right? So this motion was actually suggested by him. Now, because we have already gone through a few rounds of discussion and he initially declined, I don't want to quibble too much with him, right, about the motion. So I just, okay, whatever you want. Okay, so okay, you want to debate this? Fine, let's talk about this. But actually, I want to say something about the motion, right? Actually, this motion, which is suggested by Linford, actually it is ambiguous, right? It is why? Because this motion can be interpreted in two ways, right? The first way is that, okay, contemporary physics contradicts or a cause or a beginning of the universe. However, Linford himself admits that this is not the case, right? So he says that, well, actually, none of the theories concerning none of the scientific theories concerning what happened before the Big Bang are actually proven. And I pointed out this point as well. That was the first point, right, of my debate slide, and he agreed to this as well. Okay, right? And my very first point is that contemporary physics by itself does not provide a complete description of reality and is not able to rule out a cause or a beginning, right? So, and Linford agreed with this. So if we interpret the motion as saying that in light of contemporary physics, we should not accept, if you interpret it as saying that the contemporary physics contradict the idea that the totality of physical reality had a cause or beginning, and therefore we should not accept it. If you interpret it that way, then the debate is already over by the first point, right? Because both of us agree that actually it doesn't contradict in that sense, right? It doesn't rule out a creator, right? It doesn't rule out a beginning in that sense. So the debate will already have been over by the very first slide. Now, however, obviously, right, that is not how Linford interpreted the motion, as you can see, right, from the rest of the debate. Instead, what he meant by the motion is that he is saying that contemporary physics does not prove that the totality of physical reality had a cause or a beginning. So that is how he interpreted this. Okay. Now, and so you all need to understand the context of this interpretation. Okay. So the context of this interpretation is obviously concerning the Kalam cosmological arguments. Now, Linford claimed during the debates that God's existence is not the main topic, right? He said that. However, his publications discuss the Kalam argument, and my response to his publications also discuss the Kalam argument. So the Kalam argument is an important background. It's an important context for interpreting this motion. Okay, and the context is that Linford is trying to show that the proponent of the Kalam cannot prove that the totality of physical reality, which is what I mean by the universe, has no beginning, and therefore premise 2 of Craig's formulation of the Kalam fails. Dr. Craig formulated the Kalam in the form of three-step argument, three-step syllogism, and premise 2 is saying that the universe had a beginning, right? And Linford is trying to say that, well, you cannot prove that, and therefore, premise 2 fails. So that is the context, right, of the whole discussion. And so my response to his argument is that the Kalam's conclusion of a personal creator still holds, right? And therefore, the existence of God is relevant, right, to the whole discussion, right? Because that is how we should situate. That is the context which in which Linford is trying to argue his case, right? And so Linford is trying to show that physical reality could be without beginning, and therefore you cannot prove premise 2. And he tries to argue for that by arguing that the physical reality could have a timeless aspect that is without a time dimension, or it could be non-metric time that is with a time dimension, but that is without any change, and also without beginning. That is Linford's arguments. Now, I pointed out during the debates that the problem with his argument is that a beginningless state would also need to be initially changeless, given the arguments which I presented against an infinite regress of change. And moreover, the beginningless state will also need to have libertarian freedom to bring about the first event, which means that it is a personal creator. And therefore, the physical theories cited by Linford could not have involved timeless physical entities in such a way as to exclude a personal creator God. Okay, so that is the overarching summary, right, of the whole debate. And I also mentioned during the debates that as God freely caused the first event, God also enters into time and thereby ceases to be timeless. But when God was holding back from creating the first event, he existed without any event and hence can be timeless without the first event, right? So God doesn't have to be essentially timeless, right? God could be timeless without the first event and enter into time with the first event. I mean, that was how Dr. Craig has argued the case. However, in personal physical entity, being impersonal, they do not have libertarian freedom, right? So they couldn't have hold back its disposition from causing the first event. And so this move which I make to demonstrate that the first cause must be God, this is not available to Linford, right? Because Linford, he doesn't believe in God, right? So so he failed to explain how the initial timeless state could have brought about the first event, and so he has failed to rebut the cosmological argument. And so it is very important to note that during this debate, we are actually not talking past each other, right? Rather, I was showing that all the theories which claim that physical reality might have no beginning, all these theories are unproven, as Linford himself also admits. They are speculative, and they do nothing to rebut my cosmological and teleological arguments, which is based on what physics itself requires, right? So he's appealing to physics, but he's also appealing to unproven physical theories. On the other hand, I'm also appealing to physics and talking about what physics requires. So physics, as I explained in my opening statement, right? Physics itself requires deductive reasoning. Physics itself requires observation. And deductive reasoning and observation can be put together to formulate a sound argument, the cosmological argument, to show that God exists. Okay, so we are not talking past each other, right? I'm using his assumption, the assumption that his physical theories requires to prove that there must be a God, right? And show that he could not avoid this conclusion. And therefore, the cosmological argument stands unrefuted, and the conclusion is true, there must be a God. Now, finally, let me say something concerning the relevance of the design argument, the teleological argument. In our emails prior to the debates, I explained to Linford that, on my view, if physical reality has a designer, then physical reality has a cause. The high degree of order of physical reality is, I think, the most obvious evidence discovered by contemporary physics, which indicates that physical reality has a designer cause. And so I told him that it will not be a fair representation of the case against the motion of the debate to omit the evidence which has convinced many of the greatest scientists in history. And I have also defended the teleological argument and incorporated the teleological argument into the cosmological argument in my book. Now, Linford, he didn't raise any further objections during our email exchange, right? So initially he says, why do you mention the design argument? So I explained to him in the email, and so he didn't raise further objections during our email exchange. But during the debates, he says something like this. He says, even if the order we observe in physical reality requires a designer, which he didn't rebut this conclusion, he says that physical reality doesn't have to be caused. He says that physical reality could have existed beginninglessly in a disordered, chaotic state, only sequentially ordered design. Now, I responded to him during the debates later on, during my first rebuttal, by pointing out to him that by saying that the teleological argument, I replied by showing that the design argument is relevant. Why? Because a designer will be an efficient cause who ordered the physical reality according to its purpose, right? That's the meaning of design. And so therefore there will be a final cause as well, right? So I think many of you would know that Aristotle talked about cause using 4 ways, right? So there's efficient cause, material cause, formal cause, and final cause. So final cause is related to design, right? So the topic of our debate includes the consideration, does physical reality has a cause, right? And my argument is that contemporary physics show that physical reality has a high degree of order, which indicate that there is an intelligent cause causing the order, right? Ordering it. Now, ordering is an efficient cause, and it also involves final cause. Now, the cause doesn't have to be creatio ex nihilo, right? So I think what Linford is thinking is that if it's a cause, it must have created, bring it from nothing. But actually, no, it doesn't have to be like that, right? So a cause doesn't have to be causing out of nothing, right? Just like, you know, if I say a computer engineer caused his computer, is not causing out of nothing, right? It's, you know, designing the computer, right? Putting the parts together. Now, I do affirm creatio ex nihilo, however, it's on other grounds. Now, as for the cosmological and design arguments are concerned, I don't have to prove, natural theology doesn't have to prove every aspect of Christian theology, right? So I don't have to prove that the creator is a trinity. I don't have to prove creatio ex nihilo. All I need to prove is to show that there is a personal creator, right? That is enough to refute atheism, because no atheist I know admit that there is a personal creator, first cause, or a designer of the universe, and still be an atheist, right? I mean, if you admit that there is a designer, then you are no longer an atheist. You will be a deist, at least a deist, right? Or a theist, right? And deists and theists do believe that there's a God. And so that will be enough, right, for the purpose of the debate. Now, as I explained earlier, the context of our debate concerns the cosmological argument for God. And moreover, the design argument is relevant because it provides additional consideration for thinking that the first cause is a creator God by showing that it's a designer. Why? Because a designer is a creator, right? Okay, so so these are some of my opening remarks concerning the debate. Do you have any questions?
Yeah, as far as I understand, Dr. Craig said that it's like metaphysically impossible that universe would be eternal, because the universe, even if we speak about prime matter, it's also unstable on metaphysical foundation. So it's like it's impossible that creator also exists alongside with universe, because we already have these changes, yeah. And so this is a problem, because we go with these arguments against metaphysical changes.
Yeah, so a key issue, which is related to what you have just said, is how do we define physical, right? During the debate, I actually asked Linford to offer a definition for what physical means, since he is the one who suggested the motion, right, as I mentioned earlier on. So since he suggested the motion, then he should offer a definition of what he means by physical. However, throughout the debate, I don't remember him offering a definition in reply, right? Now, on the other hand, I did offer a definition, right? So I say that I don't think that there is physics without change, as you said just now, right? You quote Dr. Quick. And I agree, because if you think about the terms that are used in physics, right? For example, interactions, process, emergence, all these describe events or change, which is equivalent to change. Okay, so I think the term physical reality should be used to refer to changing entities which are describable by the equations of physics. And so based on this definition, physical beings necessarily cannot be timeless and beginningless as well, right? They cannot be, they cannot be beginningless and initially changeless, right? In that sense. So I think it's correct. Now, I also said during the debate that even if Linford rejects my definition, right, because he wants to say that there could be timeless physical entities, but even if he rejects my definition, he nevertheless still agrees that there is in fact no good evidence for thinking that timeless, changeless physical entities exist, right? He says that there could be, but he also agreed that there's no good evidence for thinking that there are indeed such entities. On the other hand, I've already offered a sound argument which shows that the initially changeless personal creator exists. So based on Occam's razor, we should hold to the view that the universe ultimately came from a single personal first cause rather than a personal first cause who is also physical, or a personal first cause who existed alongside a timeless physical entity. I mean, this whole issue is just like the old question of asking, how do you know that there's only one first cause rather than many first cause? Right? How do you know that there's only one God or many gods, right? I mean, this is the question that a lot of people have asked, when we present the cosmological arguments. And the standard answer, which Dr. Craig has offered in response, is that we use Occam's razor, right? Using Occam's razor, right, showing that, if one first cause is already enough, right? So we don't need to believe that there are more than one first cause, right? And then that is a reasonable principle, right? So given the absence of evidence and proof for additional first causes, we should only believe in one. And so likewise, that is my response as well to Linford, right? We should only believe that there's one first cause, one beginningless entity, and that first cause I've demonstrated that is a personal creator. And so we don't need to believe that there are other beginningless things, right? Which will be other first causes in a sense, right? It'll be a kind of material first cause existing alongside the first cause creator, right? Because there is absence of evidence or proof, right, for that. And so using Occam's razor, we should shave away, right, those entities, unproven entities, and believing that the universe is brought about by one single personal creator.
So should we move to our third point? Yeah.
Okay, the third point is that we want to discuss Linford's objection to my modus tollens argument for the causal principle. We'll show some timestamps from the debate later. But before that, I would like to, first of all, show my PowerPoint slides on the cosmological argument, right? So I formulated it in terms of a 13-step cosmological argument, and the first 3 steps is a modus tollens argument to show that whatever begins to exist has a cause. Why? Because otherwise, if something, say for example X, if X begins uncaused, then we would expect some other things, such as Y, for example, right? So Y could refer to, say, for example, electric field around me, right? And such things, the increase in strength of electric field, right? Such events, they could begin to exist around us. And in fact, they do begin to exist around us, right? So for example, when I switch on my laptop, right, the electric field increase. So my argument is that if X begins uncaused, then Y, which could be events such as electric field increasing in strength, would also begin uncaused around us. If X begins uncaused, this means that there will be no cause, which makes it the case that only X rather than Y begins uncaused, right? So that's the meaning of saying that something begins uncaused. So my definition of cause here is whatever that makes it the case that X rather than Y begins. But if X begins uncaused, then there'll be no cause, right? That makes it the case. And secondly, any properties of X and any properties of Y, which makes them different from each other in the concrete world, right? To clarify, I'm talking about the concrete world here. This will only be had by X and Y only when they had already begun to exist in the concrete world, right? So they can only make a difference in the concrete world only after these things had already begun to exist in the concrete world. But that'll be too late, right? Because after they begin to exist, then they can't make a difference anymore, right? As to what began to exist. And the third point is that the circumstance around us is compatible with the beginning of Y, right? So what this means is that the circumstance around us doesn't prevent electric field from increasing in strength. As I mentioned earlier on, if I switch on the laptop, it will increase in strength. The electric field will increase in strength, right? So what this means, what these 3 statements means, 1.1, 1.2, 1.3, what this means is that there will be no cause that makes a difference. X and Y, they also couldn't make a difference. And the circumstances, the surrounding, other things also cannot make a difference as to why only X begins uncaused but not, as to why only X begins uncaused but not Y, right? So what this means is that there'll be nothing that can make a difference in the concrete world. There'll be nothing in that can make a difference in the concrete world for to make a difference between X and Y, where beginning to exist uncaused is concerned. Okay, so this means that if X begins uncaused, Y would also begin uncaused. But that is not the case, right? So we don't experience an increase in strength of electric field suddenly without having to switch on a laptop or whatever, and we don't experience such a field that suddenly increase and shock us to death, for example, right? We don't experience such things. And therefore, it is not the case that something begins uncaused, right? So that is the modus tollens argument. So during the debates, what he basically tries to do is two things, right? He tried to formulate two objections to my modus tollens argument. I mean, he also talked about other things, which I have also rebutted, but let us focus on 2 points, right? So basically, the first point he's trying to object is that he claims that he can also formulate a symmetrical argument for a material principle. Okay? And by material principle, what he means is that it's the claim that everything that begins to exist arises from rearranging pre-existing physical stuff. Okay. Now, in my reply to Linford, I explained that actually his claim is false. Why? Because you cannot construct a symmetrical point concerning 1.1. Why? Because if x begins uncaused, this means that there will be no any cause whatever for making a case that only x rather than y begins uncaused. Whereas if you hold to a similar point cannot be formulated concerning the material principle. Why? Because if something begins without any material cause, it doesn't mean that there will be no cause whatsoever for making it the case that only that event begin without material cause. Why? Because there could still be efficient cause, right? So even if there's no material cause, there could still be efficient cause, which makes it the case that y begins to exist without material cause. And so his symmetrical arguments actually fails. Now, when we listen to the debates, we find that there is actually another deeper problem with his objection. Yeah, because he is making some assumptions which is fallacious. Okay, so he's actually operating on a fallacious understanding of cause. So I would like to show this by showing the video clip. So Mikhail, can you play the first video clip, please?
How can the material principle constrain what begins to exist? Well, suppose that the causal principle were false, but the material principle were true. In that case, the presently existing physical stuff would still constrain what physical stuff can subsequently come into existence. Hence, in the absence of the causal principle, pre-existing physical stuff would provide an antecedent condition that would make it the case that only x rather than y begins to exist.
Okay, yeah, stop here. Now, if you listen carefully, you hear what he says, right? He says, suppose the causal principle were false. Okay, and then he also says that in that case, well, the pre-existing physical stuff would still provide the antecedent condition that will make it the case that only x rather than y begin to exist. Right? You heard that, right? Now, however, the antecedent condition that will make it the case that only x rather than y begin to exist, such an antecedent condition is what I mean by cause, right? So in that case, the pre-existing physical stuff that he's referring to would be the cause. It would be the material cause that makes it the case that x rather than y begin to exist. Now, in that case, the causal principle is not false. Why? Because the causal principle is saying that whatever begins to exist has a cause, right? And the cause can be material cause. Okay. So do you notice this? Okay, so what means that so his supposition is false, right? Because he's saying that suppose the causal principle is false, which means that things can begin without any cause whatsoever. But later on, the next sentence, he says that, well, the pre-existing physical stuff is the antecedent condition that makes it the case that x begin to exist rather than y. Now, in that case, the pre-existing physical stuff is the cause, right? Is the material cause. And so it is not the case that the causal principle is false, contrary to his supposition. Do you see what I mean?
Yeah.
So the video clip which we have just played showed that, in fact, Linford misunderstood the causal principle, right? So his objection is based on a misunderstanding, right? I think he's assuming that the causal principle is just referring to efficient cause, and I think he's also assuming that my modus tollens argument only applies to efficient cause, but this is false. My modus tollens argument is saying that without any cause whatsoever, right? Without efficient cause and material cause, without any cause whatsoever, then we would expect to see other things begin uncaused, right? So that is what my modus tollens argument is about, right? So I think his objection is based on a misunderstanding of the causal principle.
Okay.
Okay, so yeah, so that's the first important point. Now, moving on. Now he is so basically what he's trying to argue, right, in the clip that what he's trying to claim is that if material principle is true, there would be material making it the case that X rather than Y exists, right? If material principle is true, there will be material, there will be pre-existing material making it the case that X rather than Y exists. Now I agree, right? Because on my view, the material will be the cause, right? But my point is that if the material principle is not true, it is not the case that there will be nothing making it the case that X rather than Y exists. Okay, and that is why Linford cannot construct a symmetrical argument. Okay, so why? Because as I said, if the material principle is not true, there could still be efficient cause, which makes the case that X rather than Y exists. Right? So I think Linford is totally confused. He's about these points. Okay. Yeah. All right. Okay. So I mentioned this. So can you show my response? I mentioned this point in my debate actually.
Yeah.
Yeah. The next clip. Let me clarify that when I defend the causal principle using my modus tollens argument, it is true that I've been focusing on efficient cause, but my argument is not limited to efficient cause. My argument is saying that if there's no cause whatsoever, right, for whatever begins to exist, then there will be nothing that makes it the case that only that thing, but not other things, beginning to exist, right? So if there's no efficient cause, no material cause, no cause whatsoever, and things just begin to exist without any cause whatsoever, then other things or changes or whatever would also begin on cause. That is the argument. Now you're trying to construct a symmetrical argument by talking about transformation from pre-existing things, focusing on what I call material cause. But as I said, that even if something can come into existence without material, it doesn't mean that other things would. Why? Because we can still explain the coming to be of the material as being brought about by efficient cause, right? So your principle doesn't exclude the possibility that there could be an efficient cause which brings about something without material.
But that's,
so there is still some cause which makes it the case that that special event happened. So it doesn't mean that anything goes, right? Yeah. Okay. So this basically shows that he couldn't construct a symmetrical argument, right, to point 1.1, and therefore his claim that he could construct a symmetrical argument to my modus tollens argument for the causal principle fails. Okay. So is it so? Okay. So shall we move on to the next point?
Yeah, should we go?
Okay, so the next point, okay, so now Linford also raised another objection to my modus tollens arguments. And this other objection concerns the law of nature and the circumstances. Okay, so can you play the next clip, please?
Yes.
I said just now, the fact that there's field right now doesn't prevent increasing in field, right? I can switch on.
Yes, it does. Look, the field has properties. The properties explain why certain laws apply to the field. That's the view that you have. And so given the properties the field has, those properties are incompatible with the field beginning to increase for no reason.
As I said, they are not incompatible, right? The fact that there is already field existing around me right now doesn't prevent me switching on the laptop, which increase the field further. And what I'm arguing is that if something begins uncaused, I don't even have to switch on the laptop. The field would increase. Yeah, that's my argument. And moreover, the properties will also change uncaused as well, right? Because if given my premise 1.1 and 1.2, there will be no difference between the changing of properties and the beginning of the universe. Where beginning to exist uncaused is constant. The universe began uncaused.
That's to confuse.
So the properties will change. Yeah, and if the properties change, the laws will change as well. Yeah.
That's to confuse whether something can happen for no reason with whether something can happen without a cause. I never made the claim that something can happen for no reason. Right? Throughout, I've been assuming that there are reasons for why things happen. In the present dialectic context, what we're talking about is we're comparing the material principle with the causal principle.
I agree. I agree too. I agree too. I agree that, and in fact, that is premise 2 on my argument, as I said, right? So things do not happen without reason. Things do not happen without cause. That is but hang on,
but
that doesn't
the
deny
fact that
reasons for premise 1, right? And you have misunderstood premise 1.3, as I said.
The fact that there's no cause that constrains whether or not something begins to exist doesn't mean that things would just pop out of nowhere. I mean, there would still be reasons that would prevent them from beginning to exist.
Well, as I said, those reasons would need to require a differentiation between x and y. There will need to be a difference between x and y. Right?
And they do.
And whatever, as I said, but whatever difference will only exist when they had already begun to exist, which means that they cannot do the work of differentiating.
No,
they had already begun.
The electric field has the properties that it has now. And those properties that it has now constrain what the electric field does in the future.
No,
that's, I mean, look, that's your view, right? You have the view. You have the view that the laws. Well, hang on, but you have the view that the laws are explained by the electric field's properties, right? So if I'm looking for a description of what properties the electric field has, I look to the laws, right? Those just are descriptions of the properties that the electric field has. And now I ask, okay, well, given that description of the properties that the electric field has, can the electric field spontaneously increase in some region for no within some region for no reason at all? And the answer is no. The properties the electric field presently has constrain what it does.
No, the answer is yes, if some things do begin to exist uncaused, because there'll be no difference between that thing and the properties of those.
No, but there is a difference. I just told you what the difference was. The difference is that some future developments are consistent with the properties that the field presently has, and some future developments are inconsistent with the properties the field currently has. That's what distinguishes between one future development and another.
Well, but this inconsistency is based on the assumption that there are properties which hold and which ground the laws that hold, right? But I'm saying that those properties, would also change without cause if something else begins uncaused. That is, yeah. So that is the key point. The last thing I just said, right? Which is that he is assuming that once there is physical reality. This physical reality will have properties that ground some laws which makes the circumstance incompatible with other things beginning uncaused, right? So that is his objection. But my response is that he is assuming that these properties will hold, right? But my argument is that these properties will not hold because if something begins uncaused, then these properties would also change uncaused, and so there couldn't be these laws that can prevent other things that begins uncaused as well. So yeah, so that is the key response to his objection. Now, and then he goes on to talk about laws being essential, right? He claimed that laws of nature are essential. So can you move on to the next clip?
Laws are explained by the essences that physical objects have, then it wouldn't be possible for the electric field to suddenly increase because, or in other words, it wouldn't be possible for its properties to spontaneously change because those properties are just what it is to be that electric field, right? If they're essential. So it seems like what's doing all the work.
No, I think that's also not true. I think that's also not true because even if you claim that the laws are essential description of objects, right? My argument will show that new objects would begin uncaused as well, right? So,
but hang on, when I was offering my objection a moment ago, you said, oh, but if the causal principle were false, then the properties that objects have could just change for no reason. And now the
properties will change, objects will change as well. Yeah, so new objects will come in existence uncaused as well.
And then the reply was that, well, if objects have their properties essentially, if that's why they satisfy the laws that they satisfy, because it's in virtue of the essence that those objects have, well then, given what essences are, they couldn't change their properties, right? I mean, that would be explanation enough, just that it's essential to those objects that they have the properties that they do.
Yeah, so if that view is correct, then it would deny one of my response. It would deny that the properties change. But actually, now actually even that I don't think is the case, because it could be that the properties change and the object becomes something else, right? So it is still, so it doesn't deny that the properties are essential to that object, but it's just that the object became something else.
Sure,
it became
if
another
it's
object.
possible.
And moreover, it doesn't prevent additional objects from emerging, right? So these are two responses. Yeah.
If it's possible, if it's consistent with the object's essence that it ceased to exist, then sure. But if it's not, if it's inconsistent with the object's essence that it ceased to exist within some circumstance, well, then that's explanation enough for why it doesn't.
Well, I think objects do change, right? So some things can change to another thing.
Some things can change, but when they do change, either what's going on is that its accidental properties, not essential properties, are changing, or the circumstances don't prevent that object from going out of existence.
Well, no, I think, okay, so for example, if you say that it is essential to water that is H2O, but that doesn't prevent the H from dissociating with the O, and you're left with hydrogen and oxygen.
Yes,
right? So you have changed.
I agree, but that's because those are circumstances that are compatible with its going out of existence. There are going to be other circumstances that are incompatible with that.
So I'm saying that if something begins uncaused, then we will see this kind of changes also happening uncaused as well, because there will be no difference between that kind of change and the first kind of change where beginning to exist uncaused is concerned. So we will have
I don't want to belabor this point anymore. I think if you want to move on to your next question, I'm happy to do that.
Okay, so that's the end of this section of our discussion. Now, so basically, towards the end, you hear Linford saying that, well, that's because there are these circumstances, they are compatible with going out of existence, and there are other circumstances that are incompatible with that. So but then he's by mentioning about circumstances, he's actually going back to the earlier point about laws of nature, such as Maxwell equation and other circumstances, right, which he claims prevent things from beginning without reason. But I already explained earlier, right, that these laws are supervenient on entities and properties, which would begin uncaused if something begins uncaused, which the existing things doesn't prevent that. So, and if those change happens uncaused, right, if those entities and properties begin uncaused, then the circumstance would change as well, right? So the circumstance will not prevent, right? Say for example, water becoming H and O uncaused, right? That it doesn't prevent that, right? Because the circumstance would also change, right? So so my point is that the necessary conditions and the circumstances will also change without requiring necessary. So my point is that the necessary conditions and the circumstances would also change without requiring causally necessary conditions if something begins uncaused, right? So he cannot use his point to deny my point.
Yeah.
Mm-hmm. Yeah. So in summary, right, that is our discussion. The main points concerning the modus tollens argument. So Linford tries to raise two main objections. The first objection is that he claims that he could formulate a symmetrical argument for the material principle, but I already shown that that is false, because he cannot formulate a symmetrical argument concerning 1.1. Now, the second main objection that Linford raised is that he claims that he tried to appeal to 1.3 and claim that the circumstances will be incompatible with the beginning of Y. Now, I've already shown that his objection is based on a misunderstanding of what 1.3 actually means, right? By 1.3, what I mean is that the circumstance around us, they don't actually prevent. Say, for example, electric field increase in strength. The fact that there's already electric field around us doesn't prevent the field from increasing in strength, right? And whatever laws of nature circumstance that he appealed to, those will require the assumption that the properties hold, right? But then given 1.1, 1.2, the properties will not hold, right? Because and anything that makes X different from Y, because there'll be no cause that makes X different from Y, and any difference between X and Y will only be had in the concrete world when these things have already begun to exist, which means that they can't actually make a difference before they begin to exist. And so given 1.1 and 1.2, right, there'll be no difference between X and Y where beginning to exist is concerned. And 1.3 also cannot make a difference, right? Because as I said, the circumstance is compatible, right, with these changes. They don't prevent electric field from increasing strength, for example, right? And so he has failed to rebut the modus tollens argument. And so given the modus tollens arguments, the conclusion follows, which is that whatever begins to exist is dependent on causes to make the case that it is X rather than Y that begin to exist. And so on this basis, I go on to talk about other premises on using the causal principle. Whatever begins to exist depends on the cause. We can then go on to formulate the rest, to derive the rest of the steps of the cosmological argument. And you will notice that throughout the debates, Linford didn't challenge this, right? He didn't object to premise 5, premise 6, 7, or 8, right? So I explained during the debates that using the causal principle, we can formulate an argument from the viciousness of dependence regress. I explained that in my opening statement in the debates, which is based, and I explained that this argument is based on the causal principle. So on the basis of the causal principle, you can formulate these arguments which will rule out an infinite regress. It will rule out a circular loop and demonstrate that it will rule out a closed loop and demonstrate that there is a causal series with a first cause. And then we can go on to demonstrate that this first cause must be uncaused without beginning and also initially changeless, as I explained in my opening statement, and also that this first cause will also need to have libertarian freedom as well, as I explained earlier on. And Linford also didn't rebut. I mean, he tried to rebut this argument, but he didn't do it successfully, right? Because I explained that during the debates that the first cause must have the capacity to hold back its disposition, right, from causing the first events, and he didn't rebut this point. And therefore he has failed to rebut the conclusion that the first cause would have to have libertarian freedom, which means that it's a personal creator. Right, so the debate is already settled, right? The conclusion is that there is a creator God, there's a personal creator. And so the rest of the things that we are going to discuss doesn't rebut this conclusion, right? The rest are just details about science. Okay, so for example, we are going to talk about Barbour's theory about timeless gravity and loop quantum gravity, right? All these are these are unproven things, but these are details, right, concerning science and possible scientific theories, but they don't actually rebut the conclusion of the cosmological argument. Okay, so we can first of all start with his claim about concerning whether physical entities are changeless. Right? Can you play the clip?
Yes.
But Andrew thinks that no physical entity could be truly timeless because all physical entities, he thinks, undergo change. But why think that all physical entities undergo change? In various publications, Andrew claims that quantum mechanical entities are always undergoing change. But Andrew is wrong. Any quantum mechanical system that is in an eigenstate of its Hamiltonian simply does not undergo intrinsic change.
Now, you'll hear earlier on that Linford refers to my publications, right? He says in various publications, Andrew claims that quantum mechanical entities are always undergoing change. Okay, so let us take a look at my publication. Where did I actually say this? Okay, so let me share screen. So I refer you to my book, The Teleological and Kalam Cosmological Arguments Revisited, on page 262. Can you see my book?
Yes, I see.
So on page 262, under 6.3, I talk about the first cause. And I mentioned here that the first cause would also be distinct from physical universe, which is constantly changing. For according to quantum field theory, the universe is a continuous fluctuating field. Additionally, as noted previously, according to quantum physics, physical entities constantly fluctuate at the quantum level. as described by the Heisenberg uncertainty principle. By contrast, the first cause is not a series of changes or events describable by physical laws, rather is initially changeless and beginningless and brought about the first events and those physical laws. To insist on calling such a first cause as physical entity would be to use the word physical to refer to something very different from what physics actually tells us about the physical world, which is inappropriate. Therefore, it is more appropriate to call this entity first cause non-physical or immaterial. Okay, so and then I go on to argue also that physical entities do not have the capacity to be the original of the event in a way that is undetermined by prior events, and the capacity to prevent itself from changing, which a first cause must have, as I explained just now, right? So I explained that such an entity would need to have libertarian freedom, is a personal creator. So here I offered a number of points, and Linford is targeting this point, right? He's saying that, well, but the quantum physics show that there could be changeless. He claims that any quantum mechanical system that is in the eigenstate of its Hamiltonian does not undergo intrinsic change, right? So he challenged what I wrote here. Now, before I respond to his objection, let me clarify a few more things first about what I wrote in my book. Now, when I say that what quantum physics, when I say in my book, what physics tells us about the physical world, I am referring to well-established physics. Right? I refer to quantum field theory, for example, right? Whereas the theories of Barbour or LQG, loop quantum gravity, those are not well-established at all. Now, Linford is not referring to those here, right? Linford is referring to eigenstate of Hamiltonian, right? I'm going to talk about that later, right? Now, that is related to well-established science. But what I'm saying here is just that because Linford later on he also wants to go and show that, well, maybe Barbour's theory or loop quantum gravity, right? He also talked about those, right? Now those are not well-established. Whereas here I'm focusing on well-established science, right? Quantum field theory. Okay, so now Linford will say that the eigenstate of Hamiltonian, that is also well-established. I'm going to reply to that later. But let me say a bit more about quantum field theory, which I appeal to. Okay, so I'm going to show this page, which is this website, which is
yes.
Okay, so this website is from a website hosted by University of Cambridge, Department of Physics, and it explains here what is quantum field theory. Okay. Now it says here that we learn in school that the basic building blocks of matter are particles, but this statement hides a deeper truth. According to our best laws of physics, the fundamental building blocks of nature are not discrete particles at all. Instead, they are continuous fluid-like substances spread throughout all of space. We call these objects fields. And then it goes on to talk about electric field, magnetic field, and then later talk about quantum field. Okay, so as you can see on this website, it says that the quantum field is a complicated object. In part, this is because it contains all of physics. The field describes vast numbers of particles interacting with a myriad of different ways. Right, so what it's saying is that quantum field is spread throughout all of physical reality. That's what it says. It contains all of physics, right? It's spread throughout physical reality. And then it goes on to say, yeah, even before I get into these difficulties, there's another reason that the quantum field theory is hard, it says. Okay, so it says here that the animation on the right shows a computer simulation of empty space. This is what the vacuum looks like, space devoid of all particles. As you can see, it is far from boring. The Heisenberg uncertainty relation, which is what I mentioned in my book as well. I mentioned the Heisenberg uncertainty principle. It says here that the Heisenberg uncertainty relation means that the quantum field cannot sit still, right? This is exactly what I said in my book, right? So instead, it froths and boils, a bubbling soup of particles and antiparticles constantly created and destroyed. Okay? So what this means is that the quantum vacuum is not actually empty, right? There are fields there, and this field is constantly fluctuating, right? It doesn't sit still, which means that it's constantly changing. So that is what I mean, right? I mean that what I'm saying is that physical reality is constantly changing, okay, according to quantum field theory. And we need to note that quantum field theory is very well established science. It's one of the best established science that we have. Now, what about the eigenstate of the Hamiltonian, right? So Daniel raised an objection by referring to the eigenstate. So let me share another. Okay, can you see my screen? Okay, so this website is taken from a lecture. It's hosted by MIT, right? It's a lecture notes on quantum mechanics taken from MIT University. And it explains here the eigenstates as stationary states. What does it mean? Okay, so you'll find here that it quotes this equation and goes on to say that from an experimental perspective, energy eigenstate do not change with time, right? So that is what Linford was referring to. No, the eigenstate do not change with time. Is therefore termed as stationary states. This and then, but then it goes on to say, that this motivates our interest in finding an energy eigenstate for arbitrary Hamiltonians. Any other state has potential to change between observations, but a stationary state lives forever if we don't disturb it. Now, notice the word if. Okay. It's saying that if we don't disturb it, then it will remain stationary. However, in the real world, okay, so this is what Linford is appealing to, right? He's referring to this. But in practice, in the real world, this never happens, right? It is never the case that it is never disturbed. In fact, it is disturbed all the time. Why? Because there are always neighboring interactions that will change the Hamiltonian and the system. Okay, so it says that if it's not disturbed, it will remain stationary. But the fact is that it's disturbed all the time. Why? Because there are fields everywhere. As I explained just now, the quantum field is everywhere. The quantum field and this field interacts, right, with the Hamiltonian. It interacts with the system, and so and as I said before, this field is also constantly fluctuating and changing. So the quantum field and also other fields like gravitational field, for example, all these fields is everywhere, and they change the Hamiltonian, they change the system. And so in reality, in actual case, in practice, it is not the case that this system is not disturbed, right? It is actually constantly being changed all the time. And therefore, Linford's citation of the eigenstate in this Hamiltonian, it doesn't rebut my arguments that physical reality is changing all the time, right? It doesn't actually rebut that. So that's the first point. Now, there's a second point, which is more important. The second point is that such a system, regardless of whether you're talking about Hamiltonian, eigenstate, or whatever, it is not initially changeless. Okay, so the eigenstate of the Hamiltonian, it is not initially changeless. It is, it still has a beginning. Okay, the state that it has still has a beginning, and therefore it does nothing to help Linford's claim that there could be timeless and beginningless physical entity. So, and that's why we find that later on Linford actually, he didn't come back to this point, right? He actually talks more about the loop quantum gravity and Barbour's theory. He tried to appeal to those other theories to try to substantiate his view that physical reality could have no beginning, right? He didn't come back to this point, right? He didn't appeal to this eigenstate of Hamiltonian. Why? Because he also knows that this doesn't help his conclusion. Why? Because these things, the Hamiltonian, the eigenstate of Hamiltonian is not initially changeless. It is saying that once it is being measured, when it has these states, if you don't disturb it, it will remain stationary, right? But the stationary state itself is not without beginning, right? It is not beginningless. So let me give an example, right? So for example, let's imagine if I became changeless from now. So if, for example, if I become frozen and changeless from this point onwards, this does not mean that I'm timeless and beginningless, right? Okay, because I still have a beginning. Right? I began to exist 1975, and I change until now. Then I suddenly become changeless. Does it mean that I have no beginning? No, I still have a beginning. Okay, so my point here is that changelessness is a necessary condition for timelessness, but and so changelessness is a necessary condition for beginninglessness, but it is not a sufficient condition. Right? It is not a sufficient, it is a necessary condition, but it is not a sufficient condition for timelessness and beginninglessness. And therefore, Linford's appeal to the Hamiltonian, I can state, no, it doesn't actually rebut my argument at all, my cosmological argument at all. Okay, yeah, let's go on to talk about the next point about interactions.
Andrew points to Wiefer's argument that fundamental physics includes various interactions, like the electromagnetic interaction, and that these interactions could be interpreted in causal terms. But interactions do not involve asymmetries that would make them good candidates for interpretation as the causal relation. Andrew claims that my arguments presuppose the direction of time is parasitic on the direction of time. Sorry, the direction of causation is parasitic on the direction of time. That too is also mistaken. If you recall in my opening statement, I talked about reciprocal relations between space-time regions.
Right. I cited Christopher Weaver, who notes that the word interaction is used in scientific and physical research. And he says that this is a causal term. And he cited the Oxford Dictionary of Physics, which says that an interaction is an effect. Right, so effect is a causal term, right? When there's effect, there must be a cause, right? Cause and effect. So it's an effect involving number of bodies, particles, or systems, as a result of which some physical or chemical change takes place to one or more of them. So this indicates that interaction involves change, involves events, involves effect and cause. Okay, so and he goes on to say that there are fundamental entities. There are 4 fundamental types of interactions between fundamental entities in our basic physical theories: the strong, weak electromagnetic and gravitational interactions. So what this implies is that causality and change are present in fundamental physics. So that was my point. And Linford, right, he tried to rebut this point by claiming that, well, but interactions do not involve asymmetries, right? So that is his objection, right? He mentioned just now in the clip that you just played. Now, what he means by interactions do not involve asymmetries is that he is referring to the equations of physics. Because if you look at from the perspective of the equations of physics, and there seem to be symmetry, right? F equals ma, right? This equals that. It doesn't tell you, which one is the cause or which one is the effect, which one, so that there is a symmetry in that sense. So from the perspective of these equations, right, there seems to be a symmetry. But as I already explained in my opening statement, these equations do not provide a complete description of reality, right? So I use so for example, I use the example of quadratic equations, right? Okay. For example, in my previous slide, I say that the quadratic equation x squared minus 4 equals 0. This can have 2 mathematical possible results, 2 or negative 2. However, if the question is how many people carried the computer, the answer cannot be negative 2. This conclusion is not based on equations, but based on causal considerations, because we know that negative 2 people don't have the causal powers to carry a computer, right? So this shows that equations is not the whole story. There are other things, right, we need to consider, which is causality, right, in fact. And I already showed just now that interaction is a causal term, right? So which means that these interactions are still, they are still events, they are still things, they are things with beginnings. And my modus tollens argument shows that whatever begins to exist would require a cause. So interactions will have causes as well. And moreover, Weaver also pointed out that these interactions are effects of something else, which means that they are in fact causality. So therefore there is causality there. So even though from the perspective of equations there is symmetry, right? But as I said, these equations do not provide a complete description of reality, and therefore they do not deny the fact that there is effect, there is causality, which physicists do recognize. And that is why they use the term effect, right? So for example, they say the electric magnetic forces acting on something, right? So there is interaction, something act on something else, which means that the phenomenon we observe is an effect of something else, right? It's effect of the forces, the interaction acting on something else. So which means that there is in fact causality there. Okay, so so Linford's objection does not rebut my conclusion that interaction indicates that there is in fact causality.
Okay.
Yeah. All right, so shall we move on to talk about the next point?
Yes, yes.
Linford spends quite a lot of time talking about Barbour's view of timelessness.
Consider Julian Barbour's approach to canonical quantum gravity, where all that fundamentally exists is a timeless distribution of properties in a high-dimensional space. While the high-dimensional points correspond to instants of time, they are not ordered by before and after relations. We intuitively think of instants of time like frames of a movie. When the frames are collected together on a film reel, the film reel provides the glue that sticks the individual frames together. Likewise, instants of time are related to one another by before and after relations. But the high-dimensional points are not connected by before and after relations, or indeed by any other temporal relation. The high-dimensional points are more like photographs scattered on a table than they are like frames on a film reel. Photographs scattered on a table can be constructed into a movie through the similarities between them. Likewise, the interrelationships between the points, what Barbour calls the best matching condition, allow one to construct a timeline. Consequently, the fundamental substructure doesn't have a location in time. Instead, moments of time are located within this fundamental substructure. Hence, without a location in time, the fundamental substructure does not have a property at some time the substructure fails to have at some other time. A function is defined as a distribution of properties over the space of possible configurations that a system might have, that is, over what's called configuration space. Now, some physicists like Aaron Schrödinger and David Bohm, and some philosophers of physics such as David Albert, Alyssa Ney, Barry Lower, and Jill North have taken this mathematical fact quite seriously. They have suggested that configuration space is the fundamental arena for quantum mechanics, and somehow grounds ordinary three-dimensional space. Now, there's a standard procedure called the canonical quantization procedure for transforming a classical theory into a quantum mechanical theory. When you apply that procedure to general relativity, you end up with a version of the Schrödinger equation called the Wheeler-DeWitt equation. As Barbour interprets the Wheeler-DeWitt equation, the fundamental arena for quantum gravity is the configuration space of possible three-dimensional manifolds, quotiented by translations, rotations, and dilatations. Barbour calls this space shape space, and each three-dimensional manifold is the configuration of our world at some time. So for Barbour, what we ordinarily think of as an instant of time is grounded in a point in shape space. We can construct C relations from the interrelationships between the properties at each of the points in shape space, that is by what Barbour has called the best matching condition. Now, given that Barbour and Wall are not discussing the same issue, it's not clear to me that they disagree with one another. But if they do disagree with one another, merely quoting Wall doesn't tell us which one of them are correct. All that I need for my arguments to succeed is that we don't know which of the two are correct.
Okay, thank you. All right, so Linford mentioned a lot of details here about Barbour's theories. He mentioned about the best matching conditions and these things. Now, so I'm going to explain all this in greater detail and mention some of my thoughts concerning these issues. But first of all, I want to begin by again emphasizing to the audience that all these theories are speculative, right? There's no good evidence for thinking that any of this is true. He's suggesting that this is a possible model, not that it's a true model. But what are all these theories about? Okay, so here I would like to recommend to you and the audience this book recently published by Oxford University Press. This book is called Out of Time, a philosophical study of timelessness. So Sammy Baron, Christy Miller, and Jonathan Tallent, this book provides a very nice summary of these contemporary speculations of these physical theories by Barbour and others. He also talks about loop quantum gravity as well. Right, so in the following slides, I'll be sharing from this book, right, because this book provides a very good summaries of their views. Okay, so what is Barbour's theory about? So just now you hear that, you heard just now that Linford was talking about the best matching condition, right? So what is it? Okay, so on page 96 of this book, it explains that the process of best matching can be understood in the following way. Imagine taking a particular point in a relative configuration space as a starting position, then take all other points in the space and compare them to this starting point. The next point is the configuration that features the smallest amount of difference to the starting position. So having defined this point, we then repeat the process until we have formed a trajectory through the space. Because we are constantly matching for the smallest difference, the idea is that this trajectory we map out using the best matching method will be extremely efficient and thus will be a path of least action. Okay, so what best matching means is that you find a point and you find the next nearest point and you find the next nearest, then the next nearest point to that, and you trace out these points, right? And what you find, and it's claimed that these points will form a trajectory through space, right? So that is what best matching means. Okay, so he goes on to the author go on to explain that we can think of a path through space of this kind as a law that describes the entire history of a four-dimensional universe, a way that all the particles in the universe evolve through time, right? You can trace these points. You can think of it as the history of the universe. And this corresponds to a Machian formulation of a theory. Now, Mach was a proponent of the relationist account of space and time. For Mach, space and time do not exist independently of physical constituents of the universe, namely matter. Rather, space and time are defined in terms of the relations between material constitutions of nature. And the best matching algorithm over configuration space is a way of defining the temporal evolution of a system in terms of the relations between the particles in the relevant configurations, right? So it's relational view in that sense. Now, Barbour takes this approach one step further. Rather than thinking of the points in the space of the universe as configurations of particles, he takes them to be geometries. What this means is that the relative configuration space is now a configuration of three-dimensional space. And the relative configuration space is populated by various states that the space itself takes. So he's saying that this space takes various states, and this place and this space and this space, they form using the best matching method. Right? He say that this form a path, right? Kind of, right? So that is what he's talking about. He's saying that that is the best matching method. So what this means is that the three. Okay, so what this is that the three-dimensional points are converted into a four-dimensional picture via the same process of best matching. This time, however, we take all the actual configurations of space and then build a path of least action through these configurations of space based on constantly matching for the smallest differences, the closest, for example, right, in the geometry. Okay? And the result of the best matching procedure is a spatial temporal manifold described by general relativity. So rather than time being a relation between bits of matter in this picture, time is the best matching relation between bits of space. Now, it is not a dimension through which space moves, but more like an algorithm that defines the dynamics. Barbour views this theory as timeless because, while one can plot a four-dimensional history through the relative configuration space, he maintains that the configuration space itself is fundamental arena of reality, and the space, however, possesses no temporal or spatial temporal metric structure. Okay, so that's why he called it timeless. Okay, so I hope this is clearer now, right? So this is what Barbour is trying to say, how time, how the fundamental reality is timeless, and he tries to say that time emerged, right, from that. Now, during the debates, I raised an objection, right? I object that this view is problematic. Why? Because if you want to talk about time emerging from something else, then that something else would need to be temporal as well. Because if there's events on the higher level that emerge from a lower level, of reality, the events will also involve the lower level in events as well, which means that there would have to be time in the fundamental structure too. Okay. Now it's very interesting that the authors of this book, which I mentioned just now, right? They also argued that time couldn't have emerged from no time. Okay, which is my argument, right? No, so if you read the next few chapters of their book, you'll find that they argue that there is no viable account of the metaphysical emergence of space-time available. The very notion that we might use to elucidate the emergence of space-time, or for that matter, time, from some non-spatial, non-temporal, non-spatial temporal structure only really makes sense within a spatial temporal or spatial temporal context, and stretch to breaking point when applied to space-time or space and time, right? So they are saying that, in fact, this cannot work. Now, it's very interesting to note that the author of this book, Out of Time, right? They did say, well, maybe this problem might be solved in the future, but they didn't show how it might be solved, right? They just on the other hand, the authors of this book, they argue that this problem of emergence, they use this problem to support their claim that time might not exist. Why? Because it cannot have emerged from fundamental non-temporal structure. So their line of reasoning is that they assume that Barbour's theory is possible, and they assume that given that it's possible, and given that time cannot emerge from non-temporal structure, therefore, it is possible that there may not be time at all. Okay, so that is the reasoning they use. Whereas I argue that time does exist. Why? Because we know that events do exist, right? There are events, which means that there are time. And in fact, Linford agreed, right? During the debate, Linford agreed with me that there are events, and this means that there is time, even though Linford thinks that time might not exist in the fundamental level. But Linford does agree that there is time, right? Even though he thinks that it might not exist in the fundamental level. And so my argument is that given that there is time, and given that there is this problem of emergence, this actually implies that time must exist in the fundamental structure too, right? Otherwise, you couldn't have this emergence. And so this actually shows that Barbour's theory is flawed. Okay, so that is my response. Okay. Now, I want to highlight a few points. The first point I want to highlight is that my defense of the Kalam cosmological argument does not depend on this, right? It does not depend on refuting the possibility of this claim. Well, as I said earlier on, it might be possible that physical reality has a timeless aspect, but still, in actuality, there must still be a first cause with dependent freedom. On the other hand, anyone who makes a claim needs to bear the burden of proof to substantiate the claim. Now, Linford claims that Barbour's theory is possible. That is his claim, right? He claimed that Barbour's theory that physical reality has a timeless aspect. He thinks that this is possible. So since he made this claim, he need to prove that this claim, this theory is coherent, right? That it provides a coherent way of showing how time could emerge from no time. But this has not been shown. Okay. And so therefore, he has in fact not shown that it is possible, right? Because there's this problem of emergence which he didn't solve, right? And so it's questionable whether Barbour's theory is in fact coherent or not, right? So it is not proven that in fact it is a possible view of time at all. So that is my response to Barbour's view. Okay, are there any questions? Is everything clear?
Okay, yeah, it's everything clear. I just think that it's like it's very crazy idea that we don't have time at all, in my opinion.
Yeah. Okay. If it's clear, then we can move on to the next one. The next clip about the loop quantum gravity.
published recently in Erkenntnis, I argued that loop quantum gravity, that the fundamental structure of loop quantum gravity, is non-temporal in the sense that it does not satisfy A, B, or C properties. And and then in my opening statement, part of what I briefly, sorry, not my opening statement, my rebuttal, part of what I briefly said was that the fundamental substructure in loop quantum gravity doesn't undergo change because it doesn't have temporal location, right? Part of what it means, according to every philosophical conception of change with which I am familiar, is that part of what change involves is that first something has one property and then it has some other, right? First there's property P and then property not P. But if something doesn't have a temporal location, it can't first be located at one time and then be located at a subsequent time and have different properties at those two times, right? So if that substructure doesn't satisfy A, B, or C properties, and it doesn't have a location in time, then it doesn't undergo change. It doesn't have any of the properties that philosophers typically think anything in time has to have. Now, why do I say it doesn't have temporal location, and why do I say that it doesn't satisfy the A, B, or C properties? Well, that's because of what's been called in the literature disordered locality. So in the way that loop quantum gravity works is that loop quantum gravity includes a kind of discrete structure that grounds space-time, right? So as understood in general relativity, space-time is continuous. Loop quantum gravity has this discrete structure. Now you might naively think, well, if it's a discrete structure, why couldn't it just be a discrete space-time? And then that wouldn't remove time from the fundamental part of the theory. Well, it's because the discrete entities and the relations between them do not correspond to the contiguity relations that you find in space-time. So the relationships among those discrete objects are a fundamentally different kind of relation than the relations that we find in the space-time that substructure grounds.
Okay, again, this is taken from the book I mentioned just now, which provides a very helpful summary. Okay, so basically what it's trying to say is that, according to this loop quantum gravity theory, is that physical reality can be described as, at the most fundamental level, by what is called spin networks. So a spin network, it can be represented by a graph of interconnected vertices and edges. So each vertex in the network represents a three-dimensional volume of space, and each edge represents a two-dimensional surface. So each spin network is taken to represent a quantum state of space, and reality itself at the fundamental level is thought to be in a superposition of spin network states. This theory is generally supplemented by dynamics to produce a full-blown approach to quantum gravity. So roughly speaking, the dynamics of loop quantum gravity involves extruding the spin network structure through a higher dimension, result in what is called a spin foam. Okay? So the dynamics generally involves the application of the Hamiltonian operator, right? So the Hamiltonian is the total energy of the system, right? And applying this using a mathematical function, which is the operator to represent this total energy, applying this to the spin network structure. And so what you get is that under this, the spin network states can persist or undergo splitting or joining to produce new nodes and edges, and thereby give the dynamics. Okay. Now it's interesting to note that the author, right, they go on to qualify by saying that we place these notions of persisting or splitting or joining in scare quotes. Why? Because they claim that there is little reason to consider the higher dimensional spin network structure to be temporal one, and thus it is not really the case that these spin network states persist, split, or join in any temporal sense. In this way, this loop quantum gravity resembles Barbour's theory insofar as it features a kind of dynamics without dynamics. That is, a dynamical version of theory managed to be dynamical without being temporal. So it's quite funny. It's quite interesting, right? Because they are using all these terms which indicate that there is change, there is time, and yet they refuse to call it time, right? And that's why they put it in quotes, right? But aren't these events, aren't these changes? Well, it seems that these are events, these are change, right? About persisting, splitting, joining, these are change, these are events that happen, which means that there is time, isn't it? So this is problematic for their view. Okay, they go on to say that the picture painted by loop quantum gravity appears to be one according to which fundamental reality is constituted by discrete chunks of space that are tied together and that then undergo various operations of splitting or joining in the dynamics. In this way, the picture resembles a lattice-like structure. Importantly, however, the linking does not introduce any spatial temporal metric into the picture, nor does it introduce any temporal ordering or metric structure. Okay, so this is the reason why they refuse to. It's because think that there is no metric, there is no ordering. So this is what Linford was referring to when he talked about the A, B, C, D theory of time, right? And basically, Linford is trying to argue that without this metric, without this ordering, there is no time, right? That's what the authors in this book are trying to argue as well. My response is that whenever there are events, there is time. Okay, so if your theory doesn't show the ordering, then the problem is with your theory, right? Is that your theory is incomplete, right? Because why? Because if there is events, there must be a dimension in which this event happened, which means that there must be time. As I explained in the debates, the presence of an event is a sufficient condition for time, right? On either the relational view or the substantial view. And so my response is that all these theories are flawed. All these views are incomplete. Okay. Now, and then the authors goes on to explain what Linford mean by disordered locality, right? So just now, if you listen to Linford, you'll hear that Linford mentioned this term, disordered locality. Now, the author of the book Out of Time, they also talk about this. They say that there is a sense in which one can treat the edges in the spin network as being like adjacency relations between chunks of space. After all, the edges are 2D surfaces which themselves connect to 3D regions of space. The trouble, however, is that there is no clear way to directly map these adjacency relations to a metric relations needed to produce a spatial temporal metric. That being said, the mapping may be possible under certain conditions, right? But they say that one of the difficulties is that the agency in the spin network does not in general correspond to anything like spatial temporal agency. Indeed, it's possible to map adjacent nodes in the spin network to regions of space-time that are arbitrarily far apart from one another. So basically what they are trying to say is that there is no correspondence between the adjacency in the network with space-time adjacency, right? So for example, with one event happening closely to another event. So they don't see this kind of correspondence. And that's why they think that fundamental reality doesn't have a metric structure, doesn't have a temporal structure. And that's why they think that it is timeless, right? So that's their reason for thinking that it is timeless. But however, as I argue, right, the problem is with their theory. I think that their theory, which is not proven, right, is incomplete, right? I know this disordered locality theory is in fact incomplete and problematic. Why? Because if there's events, then there must be time, as I argued. Now, as I also argued earlier on, right, the authors themselves also So the author goes on to say in the next page that proponents of loop quantum gravity also maintain that it is possible to identify derived structure based on the mathematical foundations of the theory, structure that corresponds to something like space-time. Thus, it is thought that space-time in some sense emerged. So once again, you'll find that the idea of emergence comes in, right? They claim that space-time could have emerged from non-space-time. However, the author of this book, right, Out of Time, Barron, Miller, and Tollens, they themselves object to the emergence view. As I mentioned before, let me repeat again. They argue that there is no viable account of the metaphysical emergence of space-time, okay, from non-space-time, right? Because the very notion, as I already explained just now, right? So they argue against this. So this is problematic. Now, the authors also note that, in fact, not every scientist who have proposed the loop quantum gravity, which is an unproven theory, not all of them actually say that fundamental reality is timeless, right? So in fact, there's no consensus about this, right? As other scientists have pointed out, there's in fact many different interpretations. There are in fact many different interpretations of loop quantum gravity. Some of these are more friendly to the idea that space-time exists than others, right? So there are different interpretations of this. Now, the reason why the authors prefer a timeless interpretation is because for them, they explain, for them what matters is whether there's any metric structure to spin networks. And they are working with the assumption that the lack of a metric structure is sufficient to say that time does not exist. Okay, so that is their assumption. But as I already said before, my response is that if there's event, it is sufficient for time, right? So the lack of a metric structure is the problem with your theory, right? Your theory is incomplete, right? So that is my response to.
Okay, so should we go to the next one?
Yeah, so the last issue we'll discuss is about the issue of non-metric time. Right? So, okay, please.
To grasp the distinction between non-metric and metric time, consider an analogy with the real line, envisioning its points as analogous to instants in time. Picture the real line as a sequence of labeled points, each marked by a number. Calculating the distance between 5 and 2 calculating the distance between 2 points on this line involves subtracting their labels. For example, the distance between 5 and 2 is 3. Now, like in non-metric time, to a set of points without labels. Without these labels, determining the distance between any 2 points becomes impossible.
Okay, should we stop or next one?
Yeah, just pause here. So this is taken from Linford's opening statement. And you will notice that in the debate, I pointed out that his use of analogy of a line, right, is problematic. Why? Because even if there are no labels, the line will still have an extension, right? They'll either is finite or infinite, right? So that is one of the objections I mentioned during the debate. Now you see how so let's now go to the next clip, which Linford's response.
I think it's important that we first become clear on what non-metric segments are. To say that a segment is metrical is just to say that the segment has a length. That's all that means. To say that a segment is metrical is just to say that the segment has a length, or an extension, if you'd like. So to say that a segment is non-metrical is just to say that the segment doesn't have a length or an extension. And so for that reason, you're right when you say that a non-metric segment is not infinite. However, you are wrong to say that if the segment is not infinite, then the segment must be finite. By definition, a non-metric segment simply doesn't have a length.
Now, let me say a few points in response, okay? So, now the first thing to note is that I'm pointing out that his use of analogy is fallacious, right? He's using this line analogy. And later when we see, because as I said, a line will still have extension, right? And then later on, he dropped the analogy and simply go on to insist that non-metrical means that there is no extension, right? So he goes on top of that. Now, I don't think that is correct, right? So I think that what non-metrical means is that there's no measure, right? There's no, as he said, label, right? No measure. But it doesn't mean that there is no extension at all. So to understand these points, I would like to share the following slide, which is taken from a book by Alan Paget. Now, this is important. Why? Because you need to understand the context of the whole discussion. The context is that Linford is claiming that an atheist can provide a parallel argument for physical reality, just as how theists have argued for the beginninglessness of God. Okay. Now, one of the views which have been offered is offered by the Oxford School, which include Alan Paget, right? So the Oxford School claims that God could be existing beginninglessly in non-metric time. And so Linford claims that, well, it could also be that physical reality exists in non-metric time beginninglessly, right? So he's trying to construct a parallel argument to Paget's. However, notice that Paget does mention about extension. Okay, so let us read from his book. Paget says here, on page 26 of his book, God, Eternity, and the Nature of Time, he says, I distinguish two senses of timeless. When time means duration in the abstract, timeless will mean that no duration ever occurs in the life of that which is timeless. Something timeless in this sense will lack any extension or location in any time whatsoever. On the other hand, by a time, one may mean a system of measured time. In this case, something will be timeless if it does not exist within any measured time. Measured time then will not apply to that which is timeless. The former sense is a non-durational timelessness, while the later sense is a durational timelessness. We can distinguish between these two senses by calling the former absolute timelessness and the latter a relative timelessness. I will argue that God is timeless in the relative sense. Okay, so here he talked about two different senses. One is absolute timelessness, one is relative timelessness. And by relative timelessness, what he means is non-metric time, right? Now, he mentioned that it's only absolute timelessness which doesn't have extension. And I agree, right? I agree that absolute timelessness has no dimension. But when you talk about non-metric time, it doesn't mean that there's no extension. In fact, Paget himself goes on to quote another scholar approvingly and saying that one of the creator's properties is his limitless extension in time, right? So Paget is claiming that it could be possible that God exists in an extension of time which is without limit, but which is infinite, right? In the sense of being limitless is infinite. Even though there's no measure, right? Even though, as I said, there's no metric. Why? Because there's no change. There's no labels, to use Linford's original analogy, right? So, but the fact that there's no change, no label doesn't mean that there's no extension. In fact, there is still extension on this view, okay? In fact, this view only makes sense in a substantival view of time. Why? Because, as I said earlier on, if you hold to the relational view, time is just a series of change. So if there's no change, there's no time, right, on the relational view. However, this view, this relative timeless view, is claiming that there is no change in the initial state. However, there is still time, right? That's why you call it this non-metric time. Non-metric time is still time, right? So so this view only makes sense in a substantival view. So the substantival view holds that time is like a kind of substance, is a kind of thing which can exist even though there's no change. And so what this means is that that thing will still have an extension, right? You will have a limited extension. It will be like a dimension of time, right? So that time will still have a kind of extension. And you need extension in order to have duration. Linford mentions the word duration, right? But the word duration implies that there is an extension, right? You cannot have duration without extension. It doesn't make sense, right? So if you deny that there's extension, then you are actually holding to absolute timelessness. In that case, it's no longer non-metric time, right? It's timeless, period. Okay, so these points need to be clarified. And so so that, right, is my clarification, my response to Linford. And in any case, as I said earlier on, Kalam argument doesn't depend on this point, right? As I said during the debate, regardless of whether there is temporal extension or no extension, the first cause, the beginningless first cause, regardless of whether it has extension or not temporally, it will still need to have libertarian freedom, right, in order to cause the first event from the initial state of beginninglessness and changelessness. Okay, so that point remains unrefuted. Now, I have also mentioned in my book that I think that both views, absolute timelessness or relative timelessness. Now, notice that I'm not talking about essential timelessness, right? Because earlier on I mentioned that I do not hold to the view that God is essentially timeless. However, I do think that God is possible that he is absolutely timeless in the sense that there is no time extension in the initial state. But when he brings about the first event, he enters into time, right? I think that's a possible view. However, I also think that it's possible. I also think that Paget's view is possible, right? I think that, on the other hand, it's also possible that God, the first cause, exists in this metricless, infinite extension, and then brought about the first events in virtue of his libertarian freedom. So I think that both views are possible and both are compatible with the Kalam argument, right? So, but the important point here is that in any case, the first cause must still have libertarian freedom. Okay, otherwise you will not be able to hold back its disposition, right, from causing the first events, and which means that it will only exist in the initial state for only a finite amount of time rather than beginninglessly, right? Regardless of how you think about beginningless, right? Whether is it a non-metric time or timelessness, right? So whether is it beginningless non-metric time or beginningless timelessness, he will need to have libertarian freedom in order to hold back his disposition from causing the first events. And then he freely exercises his freedom to bring about the first events. So in any case, the first cause must have libertarian freedom, and therefore is a personal creator, and therefore the conclusion of the Kalam remains unrefuted.
Okay, thank you. It was a great analysis. So it was very helpful, and I hope that it will be helpful for our listeners to grasp this very difficult idea. Okay, do you have any conclusion thoughts for our listeners?
Okay, so in conclusion, Linford himself admits that none of the physical theories he cited, like Barbour's theory or Look contemporary, none of this is proven, right? These are speculative physics, and they do nothing to rebut my cosmological and teleological arguments, which are based on what physics itself requires, right, which is deductive reasoning and observation. And these are sound arguments, which means that their conclusion is true, which means that the creator God exists. Now, Linford tries to rebut my modus tollens argument for the causal principle, but his rebuttal failed. Why? Because firstly, his claim that he can formulate a material principle which is symmetrical to the causal principle is actually wrong, right? In fact, you cannot formulate a symmetrical deductive modus tollens argument for the material principle. Why? Because 1.1, premise 1.1 cannot be reproduced, as I explained earlier on. And moreover, his objection from the laws of nature described by Maxwell equation, etc., is also based on a misunderstanding, right? It fails to understand premise 1.3 of my arguments, as I explained earlier on. And so the cosmological argument stands unrefuted, and also the design argument, the teleological argument, also stands unrefuted as well.
Okay, thank you so much. It was very substantive. Yeah, so it was, I suppose, one discussion, but it was very helpful, and I hope that our listeners could, from step to step, understand this discussion. So thank you so much, Dr. Loke.